Question 3 of tutorial 5. This is our differential equation, and solving the complementary equation will allow us to get yc in this form. We observe that g of x is cosine of x, hence a trigonometric function. Therefore, when we take successive derivatives, g prime and g double prime, these will alternate between cosine and sine. What we want is to produce cosine of x on the right hand side, and we would need to take the derivatives up to the second order. So to do this, we can try yp of this form: a times cosine x plus b times sine x. Then what would happen when we take derivatives is that cosine and sine will swap places, and therefore when we substitute everything into the left hand side, what we will obtain is an expression precisely of this form. We will always have a cosine term and a sine term, but maybe we will have to determine the values of a and b. And hopefully, in the expression that we get, all the sine terms will cancel out. We will use this expression. So solving the derivatives, yp prime will be this: cosine x gives us minus sine x, and sine x gives us cosine x. In a similar way, we calculate yp double prime: minus a cosine x minus b sine x. And we shall take these derivatives and substitute them into the left hand side. Upon doing that, this should be what we must get on the right, g of x. And doing so, here we will have the second order derivative and yp, and we calculate the coefficient for cosine x is minus 3a, and the coefficient for sine x is minus 3b. Comparing coefficients means that we can take b to be 0 and a should be minus 1/3, because we have minus 3a equal to 1 as the coefficient for cosine x. From this we realize that, we have a particular solution, yp, and hence the general solution is yc, as we calculated above, and we add to it yp, the particular solution, minus 1/3 times cosine x, seeing that b equals to 0, so certainly the sine term here does vanish. This is the general solution for our differential equation, and we have solved this question.